Oh, hey, didn't see you there. Best intro ever. You got it. So many viewers have asked the question, how do you get this OpenGL thing going these days? Well, I'm going to show you in the quickest, easiest way I know how. So strap on your boots and put your saddle on, leather straps. What am I even saying anymore? All right, let's get some OpenGL going. Easy mode, quick mode, awesome mode, C++ mode. You got it. As you see, it's don't look at this. Let's just open a new one, okay? New project, brand new fresh project, empty project. Let's go. We're gonna call it OpenASDF. That's the title. No, that's a terrible title. OpenGL demo. Oh, the best title. The best title. You can't get any more original than OpenGL demo. Can ya? Is that even possible? Okay, I'm a little big over here. Maybe I'll just shrink myself. How's this? You guys still see me? No, too small? Okay, we'll find a good level. We'll find a good level. Maybe about here. Code's not that important. It's all about me, right? Is that? Just kidding. All right. I know. I'm mocking other YouTubers. Okay, I can do that a little bit, right? Is it cool if I do that? Actually, I feel like I should just hide my face now. Well, too bad. It's staying. I make the decisions around here. All right, so new project. There's nothing in it. We haven't done anything. We just opened an empty project. That's all we got. x86 debug. All right, cool. So what do we need? We want to get OpenGL going. Easy. First of all, let's make a source file right over here. Whatever, that's fine. We just need a C++ file of any sort, and we're gonna go include glfw. Oh, it doesn't seem to exist. That's because I haven't grabbed the libraries for the x86 versions, because only noobs work in x86. We're going straight to x64, and of course I have that library ready to go. Oh darn, you're stuck. You're like, I don't have this library ready to go. Go watch this VC package manager tutorial. There you go. Now that you're all caught up to speed, let's continue, shall we? Here we go. So there we go, we included that. Seems sort of happy. Well, okay, we're going to be relying on Visual Studio's syntax helpers, and it doesn't update till you hit the save button. Oh, it's GLW3. Yeah, I knew that. I knew that. All right, GLW3. And we need a main, and we'll do the standard thing here because we have a reason it's not necessary, but there we go. You'll see. All right. So there we go. That's a pretty standard thing. We got GLFW3 because that's how we're going to be doing our windowing, and we're going to be putting our OpenGL context into GLFW3. GLFW3 is a windowing system. There are tons of windowing systems, tons of them, I tell you. Let's have a gander at some of them, shall we? Okay, well here we are. If you just have a general look at my upside down face, you'll see that I have brought up this website. Hold on, there we go. On chronos.org, beginner frameworks. All right, so let's talk real quickly about these different frameworks because these are sort of important. And if anyone asks why there's an upside down guy on your screen, just make them subscribe. Just go here and click the subscribe button, okay? Yeah, that's all I have to say. All right, beginner frameworks. We have whatever they're talking about up here, unofficial OpenGL SDK, collection of libraries. Okay, beginner one-shots that contain multiple tools. I haven't actually used these. Graphic and physics framework. These might be cool to check out sometime, but let's look at the context windowing toolkits, because that's what we're using. GLW3 is a windowing toolkit, and there are a bunch of others. There's FreeGlut. I've used FreeGlut before. It seems like GLFW is better in every way, so I use GLFW generally. Glut is very old. Do not use perfect description. Best description. And there's some other ones too. Some of these are pretty cool. You can look up like demos and games that are made with these. Allegro, STL, SMFL. They're used a lot in game development, especially older games. I don't know if they're used a whole lot anymore now that everybody just uses it with game engine. And we have some toolkit windows that you can put OpenGL context into. And now I know you're confused. Probably you're like, OpenGL context, what do you mean? It's just like the space that OpenGL renders to, that it tells your video card to do a thing here on your screen. So that's a very quick description of a rendering library or OpenGL in general. But it's pretty much true. Oh, okay, I got sidetracked. We've also got Qt, which, you know, is decent. I've used Qt. It's nice for making tools and stuff with C++. And yeah, you can do Open WX widgets. I haven't used it, but I've heard good things. Game GUI. I haven't heard of this one. Let's have a gander, shall we? Base rat game GUI. I don't know what I'm looking at. All right, whatever. All right, so there you go. That's the stuff. Back to your regular scheduled coding. All right, here we have a main. And yeah, we got to get some stuff going. So all we got is this plain old source. So the first thing you need to do with GLFW is initialize it. So we're just going to go GLFW3 init, and that's just a function from glfw3. That should initialize it. And this does return a value, a true or false. Returns true, you're good. So we're just gonna not whatever it is, and we'll throw maybe. Actually, you know, I don't think you actually need to do this. I'll show you in a second. Throw failed to init glfw. All right. Well, there's another cool thing you can do with glfw before you start initializing it, and you can set error callbacks, which is very cool. You just do it. You go glfw3 set error callback. I think that's right. Yep. And you got to give it a function that does a thing whenever there's an error. So we'll do error callback. I'll call it glfw error callback. And we got to build this function, but let's not do it in this file. Let's just make another header file because we want these callbacks to be static, so we can just put them in a header, and that would be super easy. Header, we'll just call it callbacks. Cool, sounds good. We'll just go static void, name of that function, and we'll just throw glfw error. I think this actually takes something, wants a signature of some sort. So there's going to be a lot of these functions, and be honest, if I go off the knowledge in my head, I will blunder some of them because there's a lot of different signatures, a lot of things you got to remember. So sometimes this syntax will help. You can highlight your function or whatever, and it'll tell you what you need. But in this case, it just says callback, and it's not quite enough. And we got to go look at that glfw error function, all that, or we could just look up the documentation. So I'm going to show you the documentation, and this is something you'll need to know going forward because it's always handy. That's why. Quick pause, guys. Just a quick pause. No, not an advertisement. Just something you need to know. It's just in case you don't. Look, it's actually rather important that you have video drivers for OpenGL, or it's just not going to work. So if you're using like a weak Chromebook or laptop that has Intel graphics drivers, all right. To be honest, this step is usually skipped for a reason. That's because your automatic updates generally handle this, but in some cases they won't. So you need to know about things like downloading OpenGL. All right, so generally the VC package manager is going to handle that on Windows, but you need to have drivers, and you're going to have these. If you've got up-to-date drivers for whatever your video card is, you should have these. Just in case you don't, and you're totally stuck being like, I don't have drivers, go here. It even talks about Linux stuff. So this one is more likely to come in handy because some Linux distros don't detect video cards right first time or something. I'm not sure. It's a little more standard on Windows right now. You just get the Win updates and they yell at you if you're missing anything critical. Hopefully, anyway. But Linux doesn't necessarily do that so much if you've got specialized hardware. All right, well, now that you know that, let's get out of this quick pause and go somewhere else. Where was I? Oh yeah, callback functions and glfw documentation. That's right, yeah. Excellent. Excellent. Most excellent. Documentation. Cool. Documentation. Wow. You guys can't see where I'm clicking because my entire body's in the way. All right, here we go. Documentation. We're there. It's all they got is here. There's this getting started guide. Include, initializing, setting a callback. So yeah, you can get a lot of the stuff that I'm going to show you here, but this is where you want to go if you just get totally stuck or want to expand beyond what you've understood. So this is your going forward guide, basically for glfw. Here's the error callback. Hey, there it is. We need an int error and a description. So it's got to have this signature. So let's copy that. Awesome. Awesome. So let's go to where the signature is. Just put that right in there, inside the parentheses. There we go. And since it's static, it's only going to get built once, and it's always going to be ready. And we can stuff with this error number, and we can do some stuff with the description if we need to. So what do they have? What do they recommend? They recommend this just fprint. We can do more than that. We can do a little more than that. Sure, why not fprint? Let's just do that. We'll also just throw, sure, because we don't want to continue if we have an error. So we'll just go ahead and throw right in our bad boy here. All right, so that's how you set a callback though. That's the easiest way. You just make header, build it in there, include it over here. Of course, we got to include our callback header. There we go, and it's ready to go. So now if this fails, we'll get that callback. So we don't necessarily need to throw here. It's already just going to throw for us. So pretty cool. I don't know if that's like the best idea. I don't know if you should still check on initialization or just expect this callback to handle it, but it's just something you can do to generally customize stuff without having to if else all over the place. Pretty handy if you ask me. I know what you're saying right now. Hurry it up. quit wasting our time. Don't worry, I'll cut this. I'll put some cuts in, but hopefully this helps you stay focused. I don't know, just my face all over the place, I guess. All right, so let's get on with it. Let's create a window. We need a GLFW window pointer to a window. Cool, and then we're going to initialize it. I could just initialize it right in line here, but I'm not going to. And well, I guess the reason is, I don't know. There's some reason. Okay, let's just do it. Okay, so GLFW functions start with the GLFW, and then you should be able to see their signature once you start typing them. There we go. All right, so we want width. I don't know, let's just do 100, 600, title, yes, title, monitor. We can put null pointer in here, share. We can put null pointer here for now. It's like options. We're not using one of them for full screen. One of them's which monitor you're on. Okay, so we've got a window. Now what we need to do is we need to set the OpenGL context to this window. And if this window has an error, this callback should detect it. So we don't need to check for null window, because we already have that going on right here. So what we're going to do here is just make GLFW, make context current, and it's this window. And then we're going to set that context to whatever our OpenGL handling stuff is. So one thing you can do is you can say define. This is for GLFW to include for you. What is it? GLFW, I don't know, something. XT one I'm looking for. Maybe it's this. I don't know. That's not right. But we're not going to do that. Instead, we're going to be using GLAD. You can also install GLAD with VCPKG. So if we just do GLAD, then we can say GLAD proc address from GLFW. GLAD. Geez, I gotta look this function up. I don't remember. It's something like this, though. Okay. Sometimes you just gotta copy pasta, you know? Sometimes you just gotta. There it is. Okay, so I think we've done everything we need to do here to get the context onto that window. Got the window created, we made it the current context, which basically means that's the one we're working on, and then we loaded GLAD's functions point to it with this whole thing here. So now we can actually operate. So basically we just want to go into a while loop, right? While, and do what? Render? Yes, exactly. Precisely. And to render, you just do glfw swap buffers and on that window. And you also want to do glfw events. And it's just like that. This basically picks up your mouse movements, key movements, and any interaction with the window. So if you don't do this on every loop, then you won't be able to get input from your main devices. So you got to do this at the end. And this essentially just renders whatever you put on the window for it. This space. So generally what you end up doing here is handling key presses, and then updating your window in the state of everything, and then swapping that to the front with this swap buffers. And that's generally workflow, but we're a little ways away from that because we're going to set up a few more things. But in general, this is good enough to work. Like if we just hit play right now, this will actually run, or should. There it goes, pops up a window with title. It's just a blank window, blank everything. So let's add a few more basics to this before we end part one. Okay, now one thing I kind of really want to do is just drive home the point of these callbacks, because we're going to be using them a lot and it's very easy for them to get confusing. You can switch between them on the fly, but you generally want to have some default ones you load up. So we're just going to go into this callbacks and we're going to make another function for our closing of our window. So in here, we're not going to do while one, because then we don't really have a good way to stop program. We're just going to use something GLFW has, which is GLFW window should close. There it is. So now what GLFW window should close, and we're going to pass the window pointer. What this does is it doesn't actually close your window. It just tells if a flag has been given that says, hey, you need to close the window. So basically we want to get out of this while loop if there's a thing that says close, and then we can close our window. And there's ways we can do that. There's I think there's a GLFW close window, for example, or whatever. There's one, but generally we're not going to use it. We're just going to use the all-in-one terminate, GLFW terminate, and then turn 0 because we're in C++ int main in this int request that we return something. So zero is going to be fine. We could change that later if this is an API where we want to return a proper value. But for now, 0 is going to mean got to the end of the program without a crash. Okay, so we exit this loop, we just go ahead and terminate, and we're done. But in theory, you could have other stuff here. You could say, okay, Now let's delete all this window stuff, make a whole new one, and open a new window. So you can have windows pop up one after another and stuff like that. You don't have to terminate, is the point I'm saying here. There's a lot of creative functionality you can do with this. You can even have multiple windows and jump between contexts to do stuff. So GLFW offers a lot of options for window control, and it's one of the reasons I like it. It seems to be pretty stable too. Okay, so back into our callbacks function. Let's just make a function to put in the close callback. Window close callback. Yes. There we go. And this wants a window. Yeah, that's all it needs. Okay, so always just be checking the documentation for these signatures if you're not sure. It will tell you right where I showed you it is before. So here we could do a thing like say we'll just printf go close, which is pretty obvious, but just so we know our callback's working, we should see this message is the point. Okay, now we do actually have to set the callback, and generally you want to set this callback before you go into your loop. So we'll just do glfw set, and there's a window close callback. Window close callback. There it is. And it just wants a function. Since we have that new function built, we'll just reference it. What was the name of it? Window close callback. There we go. That's our static one that we built, and it doesn't seem to like it. Why doesn't it like it? Because this takes two things. It takes the window as well. Gotta go to window. Or pointer to the window, and you can see that if you just hover over this function at that point, it does help you right there too. Handy things about having a nice IDE. They will save you a lot of time at times, but don't be alarmed. Sometimes they set you back too. Okay, so we've got a few callbacks in there. Let's hit play, make sure it works. Looks good. Let's close this. It says window closed, so use that callback. We didn't have any errors. If we did have errors, we'd see this error callback. Actually, I can introduce an error. So one of the things you can do before you create a window is you can set the context it is prepared for. Let me just do that real quick. This is something you can just paste in there. I want to give the window a hint for the GLFW context version major and minor. So when you go to set GLFW, or when you go to set it up, you want to make sure that it supports OpenGL 3.3 basically. And if it doesn't, it'll throw an error. So it should be fine with 3.3 because I know that this particular computer works fine with OpenGL 3.3. So no problem. But if I set this to, let's do 4.7, which isn't even out. There is no 4.7, so this should throw an error. It basically will help you catch errors with contexting at launch. As we see, we threw an error, but if we go back just a little bit, or if we go to our command line, where is it? Here we go. You'll see that it actually, with that F print right there, it actually sent this error. Driver does not support OpenGL version 4.7. No driver will because it doesn't exist. So as you can see, it did exactly what we wanted. It threw, it spat out the error, all because we have this callback, have that context check. I'm just going to leave it 3.3 for now, but if you want to check on your video card, this is something you can do, and you can loop and retry until you get the right version if you want to have like super error checking, but it looks fine. Looks like I support 4.6. It did not throw an error. So with this computer, I can go ahead and start programming with the latest OpenGL standard, as you can see. So just a cool trick that might come in handy. And I'm going to show you just one more cool trick that is super handy, and it is to make a utilities area as well and do a similar thing. So let's just make a header called utilities. There we go. And in our utilities, we want to have just functions to help along the way that we might reuse a lot. So for example, you see the window just has a title here. We could have this be the name of the program that's an argv here, because you know anything about C++, you know that argv0 is a const character array. That's the name of this. So that's the name of this program. So if I run this, my window title will have that. See here that it's awesome. There it is. All the way my entire directory. So we can make a function that extracts out just the last part of this, for example, as a utility, an example utility, and I'll just do that quick here. Go to my utilities, and I'll static turn a const char star, extract version, and we're going to take a const char star, whatever, full, we'll just call it full, and we want to end up returning something that is just the extract version. We can do that real quick. I've actually built it just a moment before hitting the old play button. We can do it with strings pretty easily, so we'll just do an include string. Now this might be different for Linux. It might be a bit Windows specific, but okay, we'll go like this. I'm just gonna do some copy and paste. Whatever, I'll type it. I can just fast forward. So we're just going to hold a few variables. Now this is terribly inefficient, but I'll explain why we're doing it the way we're doing it, how it works. Okay. Turn like that. Okay, so we just want to get the last part of that whole name of the program. So we're going to set this string equal to that whole thing, and then we're going to make a new static string, clear it from whatever it previously was. Static, of course, because we don't want to have to reinstantiate it, and we want it to stay in memory because it's a const char that needs to be in memory. Otherwise, we're going to have to copy it. So a little inefficient because it sticks in memory, but more efficient if you call this a lot because you don't have to keep redoing memory. Anyway, it could be better, but this will get the job done. So we want to go like this. We're just using substring here and like that. So it does exactly what it says here. Find last of the slash, find the last slash. And then we want to go up to, well, in substring, this is how many more spaces, and it's calculate to up to the last dot. So if we go into our source, instead of argv0 here, we put extract version. And we pass that argv0. Get it? And of course, we need to include our utilities. And since it's only static functions in there, it will be fine. Much as you want. All right, and now we see the title is just OpenGL demo. So just an example there of something you'll probably do a lot once you get to going about making a program and doing stuff, is making utility functions make your life easier. And let's go ahead and log some stuff. Logging is pretty important. You don't want to be out and all over the place. So let's just make a utility to write a log. Static const, we'll do void here. Write log, and we'll take a message. Const char star message. So what we want to do is we want to write to a file that's just a standard log for our program. So we're going to be using, of course, upstream here. We're not going to be using the old C file open and F open. That's beyond our 2020. It's too long ago. All right, that's what I'm trying to say. So our log stream, or we'll just call it logs for log stream. Yeah, that works. Thank you. Oh, it's because we have included fstream for file stream. All those libraries from the standard. There we go. So then we just need a file name, logs.open, and we can give this whatever we want. We'll just call this logs, or our log. We'll just call it our log. And we need to give it a mode. So we'll just go with append. We want to make sure we append, otherwise we're going to keep writing over. Stream, and once you overwrite this, you also need to make sure you include everything else you want, which we just want out. Yeah. Okay. And I sure hope you know how to find the default documentation for all the standard library. I'm pretty sure I say it in every video, but just in case you don't, in.cpp reference, yeah, it's this site. They pretty much got all the standards, and I think I'm using C++ 14, but your mileage may vary. You can always check what you're using by just going to your project, right-clicking it, going to properties, and then looking under general. You'll see C++ standard language. You can see there's what I'm on alt right now. It might change if you're watching this from the future. You can check and change it if you want. Visual Studio. All right, so once we've got that open, I know I keep going on side tangents, but we can just write to this. So we've opened it, and then we want to just push out a message. So we can just do it just like the old cout sort of style, and just push out that message, and then we want to close it, logs.close. And that's really it. So now we can just use that to write messages to a file, and I'll just show you that real quick. So say, well, let's just do in a callback. We have either of these callbacks. Let's print the log. So we'll go write log, whatever the description is. That should do it. Of course, we need to include utilities here. And there we go. It'll just write it to that file. And we can do the same thing here with this window closed. Say window closed. Now we could do other things for this log, like we could include the date stamp, time stamp. We could, refresh it every new run. And right now it's just going to keep appending to this log file, but I'll leave that up to someone else, and leave a comment if you do a legal one. But this is just like a getting started thing. So we don't see anything in here. Close the window. We don't see the window closed in here anymore, and that's because I wrote it. So to see that, you can just go to your directory here on my solution, open folder and file explorer, and this is just where we made our project. You'll see an rlog file there that we're writing to. And if you open that, you will just see that it has the one thing we wrote. So you can just use that utility to keep writing to that file. You don't want to use the terminal all the time. This is probably less efficient than the terminal because I'm opening and closing a file all the time, but there might be a better way. If someone wants to work on that, you're welcome to that. But another thing you can do is you can also, what I like to do is with a lot of these type of things, take an if, def, debug. So if you're in debug, you want to write to the log and then like else. So maybe if you're in release mode, you don't want to write anything. You just want to do nothing if someone calls write log because you want it to run fast. So then now if you build and debug, you'll get the log version, and if you build and release, you'll get the write log version that doesn't actually write, but it also doesn't have to open and close. So that's one way you can take advantage of this debug and release. All right, well, that's going to be it for this video. Let me know what you want to see in part 2. As of now, I'm just going to plan on start contexting some OpenGL stuff in here and start talking all about it. Peace out, guys. See you in the next episode. Don't forget to not forget to hit the like button. Bye.